Assalamualaikum and hi, my name is Putri SYAMIMI SHMSUL. My topic is inverting and non-inverting amplifier. Okay, for this schematic diagram, we use 4.7k kilo ohms for the RF1. So, connect the RF value of 4.7k kilo ohm with 1k resistor. And then connect the dual trace oscilloscope to observe both the input and the output, V in and V out.
From the schematic diagram, we need to read the graph, and to see the graph, you must click on split 2 and then move the cursor to get the value that you need to measure. So the green C1 is represent the voltage and blue line is a V out. So you need to adjust the cursor C1 and C2 to get the perfect value. And for the C1 we get negative 995.85, and for the cursor 2 we get 4.537 volt for the value.
Now I change the RF1 to 10 kilo ohms and use the same step like previous video. So for the circuit, for the graph, you need to move the cursor to get the perfect value. And now we can see at the graph, both cursor is channel 1. So you need to adjust channel 1 and see cursor 1 and cursor 2. C1 is green and C2 is a blue line. So to setting the cursor, you need to click at the C2 and cursor 2 change to PR2 V2. So now adjust the cursor to get the perfect value, and C1 is negative 998.59 millivolt and for the cursor 2 is 9.935 volt. Now for RF 33 kilo ohm, put the probe at before for 1.1 kilo ohm and at the output of 741 CD, and then run the schematic diagram and click split to get the graph. So change the and then change the C1 C2 to get one blue line and one green line. So you need to click at C2 for the cursor 2. You click PR2 V2. So now we get the one blue line and one green line. So for the cursor one, the value is negative 996.76 millivolt, and for the cursor 2 is 13 volt. So this is calculation for the inverting amplifier. AV equals to negative 4.7 kilo divided by 1k, and we get negative 4.7 k. And for V out is AV plus V in. So now AV is negative 4.7 k times negative 1. So V out get 4.7 volt. So now is calculation for 10 kilo ohms, AV divided by 10 kilo ohm divided by 1k, and we get negative 10k. For the V out is AV is negative 10k times V in is negative 1. So we get 10 volt. Now is calculation for 33 kilo ohms. So AV equal to negative 33 kilo ohm divided by 1k, and we get negative 33 kilo ohms. And for the V out is AV times V in, and now AV is negative 33 times with negative 1 volt. So we get negative 33 volt. For the first question, why the output waveform has been clipped? Output clipping can be caused by exceeding the input common voltage range or the input differential voltage range of the amplifier. Clipping can also occur when the output voltage range of the amplifier is exceeded. And the second is, why is Why is it called an inverting amplifier? It is called inverting amplifier because the op amplifier change the phase angle of the output signal exactly 180 degrees of the phase with respect to the input signal.
Now is non-inverting amplifier.
The same step like previous video, and click run to see the graph and click split, and then pause the schematic diagram and move the cursor to read the perfect value. So C1 is 994.07 millivolt, and for the cursor 2 is 5.5897 volt for the cursor 2. Now change the resistor 4.7 kilo ohms to 10 kilo ohm, and then delete the probe and put back. So put back the probe at the same place, V1 and V2. After that, run the schematic diagram. So after run the schematic diagram, you can click split button at the bottom to see the graph. So based on this graph, for 10K, the cursor one is 998.03 millivolt, and for the C2 is 10.951 volt. So click the resistor Rf1 and change the 10 kilo ohm to the 33 kilo ohms, and put the probe at the same place, probe 1 and probe 2. Then run the schematic diagram, and then just split to see the graph. So cursor 2 is for V2. For the C1, the value is 997.54 millivolt, and for the C2 is 13.005 volt. So this is a calculation for non-inverting amplifier. So for the AV is 1 plus 4.7K divided by 1K. so we get 5.7k. For the V out is AV times V in, so AV is 5.7k and times V in is 1 volt, so we get 5.7 volt. Now is for 10 kilo ohm. AV equals to 1 plus 10 kilo ohm divided by 1k, and we get 11k. So for the V out is AV times V in, so AV is 11k times 1 volt, so we get 11 volt for the V out for 10k. Now is calculation for 33k. AV is equals to 1 plus 33k divided by 1k and get 3.4k. And for the V out is 34k times 1 volt and get 34 volts. The first question is, why is it called non-inverting amplifier? An amplifier that produces an amplified signal at the output having a similar phase as that of the applied input is known as the non-inverting amplifier. This simply means that for an input signal with a positive phase, the output will also be positive. And the second question is, why does non-inverting mean if a sine wave is connected to the operational amplifier positive terminal? Is in the configuration, the input voltage signal Vin is applied directly to the non-inverting positive input terminal, which means that the output gain of the amplifier become positive in value in contrast to the inverting amplifier circuit. Discussion and conclusion. Discussion of this lab task is the value of theoretical and the measure for the post is quite similar. So the conclusion is student able to demonstrate an inverting operational amplifier circuit and non-inverting operational amplifier circuit. Also, to investigate the operational amplifier voltage follower.